Just days ago, NASA's deep space monitoring systems picked up a signal so baffling and unusual that scientists around the world are stunned. Could this be evidence of extraterrestrial life? Or is there another explanation? This could be one of the greatest cosmic mysteries of our time. NASA's Deep Space Network, in collaboration with the SETI Institute, detected a repeating signal from a galaxy approximately 500 million light-years away. This isn't the first time such signals have been discovered, but the pattern and strength of this one are unlike anything seen before. The signal, officially named FRB-292b, is categorized as a fast radio burst, or FRB. These bursts typically last only milliseconds, but FRB-292b repeats on a predictable cycle and carries an unusually strong electromagnetic signature. Fast radio bursts are intense flashes of radio waves from deep space, first discovered in 2007. Some believe they're caused by collapsing neutron stars or magnetars, while others suggest black holes as the source. However, FRB-292b's unique pattern has even seasoned scientists questioning these theories. One conventional explanation is that the signal comes from a highly magnetized neutron star spinning at an unusual rate. But the energy of FRB-292b is far greater than what a neutron star could typically produce. This opens the door to more exotic possibilities. Could it be a form of communication from an advanced civilization? The repeating nature and strength have led some to suggest it might be intentional. Even the SETI Institute is paying close attention. Not everyone agrees with the alien hypothesis. Some experts argue our limited understanding of cosmic phenomena means natural explanations we haven't yet discovered might exist. This isn't the first time we've detected unexplained signals from space. In 1977, the famous WOW signal was picked up by Ohio State University's Big Ear radio telescope. It lasted 72 seconds and was never detected again. Similar mysterious signals have come from Proxima Centauri and other nearby stars, but often end with inconclusive results. But what makes FRB-292b stand out is the persistence and strength of the signal. It's not just a one-time event, it's a recurring phenomenon, showing up consistently over time. This persistence has allowed scientists to study it in greater detail and apply new analytical models. The scientific community is also exploring if gravitational waves are involved. Could this signal be accompanied by gravitational distortions? If so, it would link FRB-292b to massive cosmic events like neutron star mergers. Additionally, there's growing interest in how the signal might interact with dark matter. Some researchers hypothesize that dark matter could play a role in amplifying or even generating these signals. It's a speculative but fascinating area of study. Beyond the scientific debate, there's also public fascination. On social media and forums, theories range from secret military technology to interstellar beacons set up by advanced civilizations. While many of these ideas are purely speculative, they highlight how deep space signals capture our collective imagination. So what's next for FRB-292b? NASA and international observatories are dedicating more resources to monitor it. The upcoming Square Kilometre Array and the James Webb Space Telescope could provide invaluable data. These advanced tools will help us decode the origin of the signal and perhaps even rewrite what we know about the universe. It's also worth noting that international collaboration is key. Astronomers from countries across the globe are sharing data, theories, and findings. This collaborative approach increases the chances of understanding FRB-292b more quickly and accurately. Whether this is a message from an advanced civilization, a previously unknown cosmic event, or something entirely different, one thing is clear. The universe still holds mysteries far beyond our understanding. But let's dive deeper into what makes signals like FRB-292b so captivating, and why scientists dedicate so many resources to uncovering their origins. First, consider the sheer scale of the universe. There are estimated to be over 2 trillion galaxies in the observable universe, each containing billions of stars. The possibility that intelligent life could exist somewhere else is not just science fiction. It's a statistical probability. When we detect a signal that repeats in a structured manner, it reignites age-old questions. Are we alone? Or is someone or something out there trying to make contact? Astronomers employ various tools to decode these signals. Radio telescopes, like the Arecibo Observatory before it collapsed, and the Very Large Array in New Mexico, can capture a wide range of radio frequencies. Scientists then analyze these frequencies for patterns, modulations, or anomalies that could suggest artificial origins. In the case of FRB 292b, researchers have used machine learning algorithms to detect subtle variations in the signal's timing and strength. These technologies can differentiate between natural cosmic noise and potentially engineered patterns. Some preliminary data suggests that the intervals between bursts are not entirely random, which has led some to propose that we might be observing a form of coded transmission. To understand the implications, we must also examine the Drake equation, a formula used to estimate the number of communicative civilizations in the galaxy. While the equation includes many variables, improvements in exoplanet discovery and signal detection continually refine our estimates. The more we understand about the conditions that support life, the closer we get to assessing the likelihood of intelligent life sending out signals like FRB 292b. There are also ethical and philosophical dimensions to consider. What would it mean for humanity to confirm that we are not alone? How would governments, religions, and societies react to such a discovery? Historically, the mere suggestion of alien life has sparked intense debate and even fear, yet it also fuels innovation and curiosity. Some scientists argue that before actively seeking contact, we should first understand the risks. What if the civilization emitting these signals is far more advanced and has intentions we can't comprehend? This line of thinking is often referred to as the dark forest theory, the idea that advanced civilizations stay quiet to avoid being targeted by others. On the flip side, proponents of active SETI, the search for extraterrestrial intelligence, believe that establishing contact could usher in a new era of knowledge and collaboration on a cosmic scale. Additionally, FRB 292b has inspired a renewed interest in alternative methods of communication across the stars. Some researchers speculate that advanced civilizations might use neutrinos, gravitational waves, or even quantum entanglement to send messages, technologies far beyond our current capabilities. We also can't ignore the role of pop culture in shaping public perception of these discoveries. Movies like Contact, inspired by Carl Sagan's work, and series like The X-Files have kept the possibility of extraterrestrial communication in the cultural zeitgeist. Every new signal discovery adds fuel to the fire, blending scientific inquiry with imagination. And let's not forget the ongoing efforts to catalog these signals globally. International databases are being formed to keep track of all FRBs detected so far. This collective effort could one day reveal patterns that individual observatories might miss. The future of deep space exploration looks promising. Missions like Breakthrough Listen are scanning the sky for signs of intelligent life, and private companies are developing more sophisticated telescopes and listening devices. As technology advances, so does our ability to interpret these cosmic puzzles. Ultimately, whether FRB 292b is a cosmic anomaly, a natural event we don't yet understand, or a message from an alien intelligence, it serves as a reminder of how much there is left to explore. The universe is vast, mysterious, and still holds countless secrets waiting to be uncovered. But let's imagine for a moment that we actually do make contact. What would happen next? International protocols, known as first contact procedures, exist but are largely theoretical. The SETI post-detection protocols suggest transparency, public disclosure, and scientific verification before any official response. However, these protocols are not legally binding, and there is debate over who should respond on behalf of Earth. Furthermore, some experts suggest that we may not even recognize an alien message if we see it. Their methods of communication, logic, or even mathematics could be so different from ours that we may misinterpret or entirely overlook their signals. This is why interdisciplinary studies, combining linguistics, semiotics, mathematics, and astrophysics, are crucial in our search. Consider also the psychological impact on humanity. Confirmation of intelligent alien life could profoundly affect human culture, philosophy, and self-perception. Some people may feel a sense of unity, while others might experience existential dread or fear of the unknown. Religious institutions could interpret the discovery in varied ways. Some may see it as confirmation of divine creation, while others might view it as a challenge to traditional beliefs. Philosophers and ethicists would also weigh in on the implications of our cosmic loneliness coming to an end. Another important consideration is the potential technological disparity. If an alien civilization can send signals across galaxies, their technology is likely far more advanced than ours. This raises both excitement and caution. Would they be benevolent explorers, indifferent observers, or something else entirely? In recent years, interest in the search for extraterrestrial intelligence has surged, driven by private investments and public curiosity. Companies like SpaceX and Blue Origin are pushing the boundaries of space travel, which might one day allow us to explore these signals more directly. But beyond the private sector, there are numerous nonprofit organizations and academic institutions committed to this cause. The Breakthrough Initiatives, for example, not only fund Breakthrough Listen, the most comprehensive search for alien communications ever undertaken, but also Breakthrough Starshot, a project aiming to send tiny spacecraft to the Alpha Centauri star system at a fraction of the speed of light. These projects reflect a broader human ambition, the desire to transcend our solar system and venture into interstellar space. The Voyager probes, launched in the late 1970s, have already entered interstellar space, carrying with them the golden records, time capsules of Earth's culture, sounds, and greetings in multiple languages intended for any intelligent life that might encounter them. Parallel to these efforts, advancements in artificial intelligence are revolutionizing how we analyze cosmic data. Machine learning algorithms can now sift through vast datasets from radio telescopes, identifying potential signals of interest much faster and more accurately than human researchers alone. This technological synergy of AI and astronomy accelerates our ability to interpret the cosmos's hidden messages. Furthermore, there is a growing interdisciplinary field known as astrobiology, which combines biology, geology, chemistry, and planetary science to understand the conditions necessary for life beyond Earth. Recent discoveries of extremophiles, organisms that thrive in Earth's harshest environments, expand our understanding of where life could exist elsewhere in the universe, including on moons like Europa and Enceladus, which harbor subsurface oceans. In addition, space agencies around the world are planning missions specifically designed to search for biosignatures, signs of life, on exoplanets. The European Space Agency's Ariel mission, for instance, will survey the atmospheres of hundreds of exoplanets, looking for chemical traces that could indicate life. With all these initiatives, the line between science fiction and reality continues to blur. Theoretical physicists are even exploring the concept of warp drives and faster-than-light travel, ideas once relegated to the realm of Star Trek. Although still in the early stages of theoretical development, these concepts keep the dream of interstellar exploration alive. Public engagement remains crucial in this quest. Crowdsourced science platforms like SETI at Home have allowed everyday citizens to contribute computing power to analyze radio signals from space. This democratization of science fosters a global sense of participation in the search for extraterrestrial intelligence. Moreover, international collaboration is key. The United Nations Office for Outer Space Affairs has discussed the potential protocols for dealing with extraterrestrial contact, although no concrete policies are in place. A unified global response would be essential in the event of a confirmed detection. As we gaze further into the universe, we must also look inward. What does the search for alien life say about us? It reflects a deep-seated yearning to understand our place in the cosmos and to connect with other intelligent beings. Whether we find life beyond Earth or not, the journey itself expands our knowledge, empathy, and appreciation for the fragile, singular planet we call home. So, the next time you hear about a mysterious signal like FRB 292b, remember, it represents not just a scientific anomaly, but a beacon of curiosity. A reminder that we are part of a much larger cosmic story still waiting to be written. Thank you for joining us on this exploration of the unknown. If you enjoyed this journey through the universe's greatest mysteries, be sure to like, subscribe, and share. Until next time, keep looking up, because the answers we seek might be waiting among the stars.